Okay, so in today's videos, we're gonna get out a sheet of paper. We're gonna label this under Q, and we're gonna alphabetize our notes. And today we are focusing on quadratic inequalities. We are focusing on quadratic inequalities. And I'm gonna teach you two helpful rules in order to solve this. By the way, this also applies to absolute value inequalities. The rules are one and the same, so you don't need to guess and check. Okay, so I'll teach you a trick. Okay. The first thing is we're going to purposely spell the word less than wrong. We're going to do less than with A and D. Always less than means and. Can you say that? Great. And means together. Can you repeat that? Great. 100% of the time, when there's a less than with the quad, and by the way, let's define the word quadratic. Quadratic just means x squared, right? An absolute value would mean anything with brackets like that. Okay, vertical brackets. And when I say less than, it's pointing to the left. And when I say together, 100% of the time, it's going to be like this. So with your example, I'm just going to pull this up, my second screen. Hopefully you can see this. So an example of this problem would be less than, something like this. Okay, so basically if you see something like an example with 6x squared minus 54 is less than or equal to 0, we can factor this out. Pull out a 6. You can just divide by 6 first, so you don't need it. If x squared minus 9 is going to be less than or equal to 0. And you're going to factor this out here. It's going to be x plus 3, x minus 3. That's called a difference of two squares, right? And just as a review, we know that a squared minus b squared is going to be a plus b, a minus b. Okay, this is called a difference of two squares. Can you just repeat this row real quick? Okay, good. So this is going to apply here. One's positive, one's negative. We basically just square root these ends. We learned this in integrated 2 last year. Is less than or equal to 0. Now, what we're going to do is we're just going to solve for these zeros. Okay, very, very straightforward. So x plus 3 is 0, x minus 3 is 0, such that your x boundary points are going to be x equals negative 3 and positive 3, add 3, negative 3, easy, right? Okay, so what you're going to do is instead of plugging and guessing and checking, I mean, your teacher will probably tell you to like do something like this, like test -4, test 0, test 4, and then you're going to like, it's going to end up being rejected. It's going to end up being okay here and rejected. But I'm telling you, you don't need to do that. I mean, if you're required to do this, I've seen this in some classes, you can plug in -4, -3, 0, 3, and 4, etc. But if you're not required to do it, this is the shortcut. Less than means and means together. All you got to do is this, -3, 3. And we're going to look at the signs here. Whenever there's a line here, it means a closed dot. And that's all you're going to do. Boom. Let me think of a U try. So let's do a U try here. Boom, boom, boom. See, less than. Oh, actually, you know what? Actually, instead of doing a less than, let's do this one because it actually follows the same. Okay, so, um, you know, changing, since we're going to do both quadratic and absolute inequalities, maybe we can just like cross this out and label this I for inequalities. Okay, and then we can do A quadratic and B absolute value. Okay, so this is your A right over here with an absolute value inequality. This is your B right over here. I mean, sorry, with a quadratic inequality. This is your B. This is going to be your absolute value inequality. Okay, and I literally just like follows the same rule. So the problem is 3 times the absolute value of 2x plus 7 plus 7, which is less than 4. Okay, so step 1 is get the absolute value by itself. Okay, so we're going to get the absolute value by itself. What did I just say? Okay, good. So what we're going to do is we're going to -7 on both sides. 3 times the absolute value of 2x plus 7 is less than -3. This is going to be a weird problem because it's actually going to be like a special solution. Not the best problem to do, but when you isolate this, well, unfortunately, it's going to be -1. Okay, if it wasn't positive, I could give you like a side example over here of what to do. But absolute value is always positive, right? AV is always positive. Why? Because it's distance from 0. You can never be at like a negative distance. Even if you're buried underneath the ground, like I always draw this picture here. I don't know why I would bury you underneath the ground, but if I bury you underneath the ground, if you're 5 feet tall, standing on top of the earth, underneath the earth, you're still 5 feet tall. If you run a mile backwards, you still run a mile, not -1 mile. Okay, so since this is always positive, a positive can never be less than a negative. So this is a special solution. This is going to actually be no solution. All right, like that. However, as a side example, let's say we had 2x plus 7, and we're going to make this less than, oh, I don't know, 7 here, like, I don't know, like 11 or something like that. Now, what you can do is you can split it up. Less than means and means together. We can say 2x plus 7 is less than 11. And what I teach my students to do is to say and right over here. And we're just going to squeeze this in. 2x plus 7. And there's this rule here. When you split up inequalities, absolute value inequalities, this flips and this becomes negative. It's just a rule. Okay, you can write that down if you want to. Then you very simply just solve. Minus 7, 2x less than 4, divide by 2, x less than 2, minus 7. 2x is greater than negative 18, x is greater than negative 9. And look, lo and behold, look, if you do it right, look, this is greater than negative 9 and less than 2. And there's no line here, so this open. Boom, okay? So we've taken care pretty much of the less, and then unfortunately for us, less than means and means together, it rhymes. All right, let's go on to the other progression now. So number 2, and this applies both for quadratic and absolute value inequalities. And fortunately for us, we're going to spell great wrong. We're going to spell like great or, like that. Great or means or by definition. And if and means together, or means, you got it, means apart. So 100% of the time, it's going to go like this. One's going left and one's going right. Let's see if I can apply it to one of the problems that you sent me. This one, perfect. Okay, so we have 2x squared plus 5x is greater than or equal to 12. Okay, the first thing you want to do, your step 1, is to move the number. Okay, and what we want to do is we want to put it into something called standard form, which is ax squared plus bx plus c. So what we're going to do is just minus 12 on both sides. So we have 2x squared plus 5x minus 12 is greater than or equal to 0. You should be familiar with the Xbox method of factoring. So what we're going to do is we're going to do first times last here. That's negative 24x squared. The middle number is going to be 5x. And you want to find two numbers that multiply to negative 24 that add up to 5. Okay, no guessing and checking. The numbers are positive 8 and negative 3. If you're not sure whether your mental math is shaky, you can just start writing down the factors of 24 and adding and subtracting in your head. 25, 23, no. 2 and 12, 14, 10, no. 3, 8, 5, and 11. And yeah, that works. Okay, so we just play around with the signs now. It's got to be positive. So what you want to do is you want to make your box right over here. You know, this is going to be 2x squared negative 12. And these two can go in any order, 8x and negative 3x. And what you want to do is you want to go up, up, left, left, and pull out the GCFs of each column and row. Here it's 4. Here it's x. Here it's 2x. And here it's 3. Now, what we want to do is we fill out the signs last. Whatever signs are here are associated with these problems. So positive and negative right over there. Just do your mental check. 2x times x, 2x squared, 2x times 4, 8x, negative 3 times x, negative 3x, negative 3 times 4, negative 12. So we know that it's going to be 2x minus 3, and x plus 4 is greater than or equal to 0. Again, we're going to solve for x. Add 3 divided by 2. That's going to be 3 halves. Minus 4, your other boundary point is negative 4. And you know, if you want to, like, once again, I don't know, you're going to have to ask your teacher if they want you to plug in values. Some teachers do. So you could plug in negative 5, negative 4, 0, 3 halves, and 2 if you want to. But great or means or. We're going to repeat that again. Or means apart. So what you want to do is you have negative 4 here, 3 halves. Look at the type of dot. It's filled in because of that line right over there. 100% of the time, it's going to look like that. When you get to more complex problems in pre-calculus, like specifically like rational functions, like if you have stuff like this, and later on, I'm not sure if you're going to do this or not. I actually forget x plus 5, x plus 7 over x minus 3. You're going to have to take all these boundary points, and there's no trick for this, unfortunately. You're just going to have to plug them all in. But for now, insofar, this is not a quadratic inequality. It's like a rational function. So insofar as it's quadratic or absolute value, you can either factor, solve, and apply the rule. Or if it's like absolute value inequalities, split it up, flip the sign, make that negative, and then, you know, it'll naturally either be less than means and, great or means or. Okay, let's see if I can find a U-try here. No. No. Yeah, dude, this is a perfect U-try. It's a perfect U-try. So here, you try. X squared minus 4x minus 5 is greater than 0. Okay, let me see you work. or means apart. Boom. And boom. All right, good. Fist bump. Boom. All right. So there you go. And then the rest of the stuff is just gonna be general shading. We have some graphing here, right? So it's very, very straightforward. I mean, you're just going to use your calculator to find some tables of values here, or just use slope-intercept form. And then very, very simply, like for graphing, if you want to get out a new sheet of paper, you can. You don't have to. We're definitely going to label this under I and take alphabetical notes as needed. And so you could label this graphing inequalities, okay? Very, very easy. Whenever it's greater than or equal to, you just shade up. Less than or equal to, you just shade down or shade below. Super easy. Okay, this is the shading. I mean, if it's greater than or less than, it just means you use a dashed line, or some people say dotted, like this, or like this, or whatever. It could even be absolute value, right? Greater than or equal to or less than or equal to, this just means solid. So, you know, it could be like this, like this, like this, or whatever. Super straightforward, okay? All right, so that will conclude this video. I hope it was helpful.